So hello students, in this particular part of the topic, we're going to learn 3D geometry, mensurations of only cubes in cuboid. And in the next part of the video, we're going to learn 3D geometry of say sphere, hemisphere and cone and cylinder. Okay, cone and cylinder, sphere and hemisphere. So it will going to be in the three parts. First part would be cubes and cuboid. Second part would be uh, cone and cylinder, and third part would be sphere and hemisphere. So we will going to do in 3 days this topic. And when we are learning this particular chapter, first of all, let's understand what is the importance of this particular topic. Say mensuration is basically used for the measurement. Say like suppose we have to measure like what is the volume of particular object, or what is the surface area of particular object, or what is like the base area of that particular object. Then we should know how that calculations happen, and for that this particular topic will going to help us. Okay, now so many people will ask, sir, why we have to measure all these things, or what is volume, or what is surface area, and all that. Many questions might be there in your brain right now, but don't worry, stay tuned. Slowly, gradually, as we will go ahead with this topic, I'll keep explaining what is exactly meaning of all these small words like volume, surface area and all. Okay, so stay tuned and I'll help you ahead in the chapter. Okay, so first of all, say one dimensional. One dimension, we have a line. And now that line has been stretched like this, either horizontally or vertically, you can say. Then we're going to get two-dimensional shape. And then that two-dimensional shape would be nothing but square, isn't it? If all the sides are equal, then that particular shape would be called as two-dimensional shape would be called as square. And now understand, students, if we'll stretch this sphere horizontally or vertically, we're going to get three-dimensional solid. And then that three-dimensional solid would be called as cube. Yes, correct. That three-dimensional solid would be called as cube. So I hope you understood one-dimensional is line, two-dimensional is square, and three-dimensional it is cube. I hope you understood till here. Pause the video and draw these diagrams quickly in your book. Hurry up. So students, what are the examples of the cubes? There are Rubik cubes, then there are some toys, and then there are what we call these, we play that snake and ladder or Ludo, that is called as dice. And these kind of toys, there are many objects, like you must have seen by now, they're in cubes in shape, isn't it? Now please write on this few example or few toys names so that you'll be able to memorize what exactly is cube is while revision. Okay, and now it's time to move to learn few formulas of, say, what is volume. So what exactly is the volume? Say suppose if this cube is empty, and if we fill water in it, so the water is completely say till this rim of this cube, then that volume or that amount of water would be called as volume of this cube. Are you understanding? So what exactly is volume? Volume is nothing but space inside the particular object, or else the amount of space which is available inside the object is called as volume. Now what exactly is surface area? So say how many surfaces would be there? Please try and understand. Say there are three surfaces, like one is red, so top would be red and the bottom would be red, front would be yellow and the back would be yellow, and the right would be green and the left would be green. So there are six surfaces. Now each surface would be in which shape? Each surface would be in square in shape, isn't it? Each surface would be in square in shape. So how many surfaces are there? Six surfaces. So what will be the six surface areas? It will become side square into six. What will be the volume? Side into side into side. So all that things we're going to see with few with few list of the formulas. Okay. So look at this, student. This is a cube. This is an example of cube. Okay. Now the each side is called as A, or else you can say side A. Okay. Now if the base is A, even the height is A, and the width, or you can see over here, this is the width. This width is also A. Now in that case, if that is a cube with length, breadth, and height, if all are A into A into A, then volume of cube will become A cube. Surface area will become one area. One area would be, say, side square, or else you can say A square. Then there are such 6 areas. So that's why surface area of the cube will going to become 6A square. Student, keep writing, okay? So it will become 6 side square. Now diagonal. Diagonal is generally denoted with letter D. And now where is the diagonal? See, students, understand. I'll draw in front of you where is the diagonal. Say, look at this. This corner to this corner would be called as the diagonal. Or else from this corner to this corner would be called as diagonal. Or else any left corner of top to the right corner of the bottom would be called as diagonal. And then the diagonal formula is root 3 into A. Root 3 into A. I'll show you how exactly all these things. Don't worry. Stay tuned. I'll just show you everything in detail. But by now, just write it on all these formulas in a sequence. Now, what is edge? Edge matlab this side. If volume is given to you, if you'll just do, say, cube root of volume, you're going to get the side. Are you getting it? So A stand for edge. Edge nothing but side of the cube. V stand for volume of cube. And D stand for diagonal of cube. I hope you understood till here. So you can pause the video, and if you're not finished, write it on all these things and go ahead. Okay, students. So now I'll teach you how to find the surface area. What do I mean by surface area? Say, look at this. This is given that, let's say, side is equal to 5 centimeter. Okay, this is 5 centimeter. Okay, this is a cube with side 5 centimeter. And now we are trying to figure it out. What would be the volume of it? So what will be the volume, students? Come on, help me. Volume is equal to A cube. So it will become 5 cube. So it will become 125. Say if it's centimeter, so it will become 125 centimeter cube. Remember that everything in the mensuration has a unit. Let's say length, breadth, height, volume, surface area, diagonal, everything has a unit. So remember that if you'll miss out the unit, you'll miss out the mark. So I hope volume is very clear. Now we have to figure it out. What would be the surface area? Surface area. Okay, or you can say total surface area. So what will be the total surface area over here? Look at this. This is pink in color, this is green in color, this is blue in color. So these are like the only 3 surfaces which we can see from the top side or else from the front side, isn't it? But we all have seen cube many times, and you can see that if this is green, that means the bottom is also green. If front is pink, then that back is also like pink. If the right, okay, this is called as left is blue, then even the right would be blue, isn't it? So there are basically, you can see the open figure of this cube over here, isn't it? Now we have to calculate, or we have to figure it out, what will be the surface area. So what basically we're going to do, say, like, this would be 5 into 5, 25 centimeter square. And now such there are 6 surfaces, 1 2 3 4 5 6, or else you can figure it out something like this way, 1 2 3 4 5 6. So what will be the surface area in that particular case? It will become 6a square. Now A over here is 5, so 5 square will become 25, 25 into 6. 6 into 5 square. Now some people will do 6 into 5, 30, and then they'll do square. Then obviously that will go wrong. So student, you should be very careful. 5 square पहले करना पड़ेगा. So 5 square will become 25, 25 into 6. 25 into 6 will become 150. And now area hai, so iska unit rahega centimeter square. If it's volume, then it is centimeter cube or unit cube. Area hai unit square. I hope you understood, guys. That's how we're going to calculate the surface area. And now If someone would have asked, okay, calculate lateral surface area or else area of four walls, in that case the green one, the top and the bottom, is supposed to be ignored, is supposed to be ignored. Students, understand student what I'm trying to tell you. So in that case, what will be the lateral surface area or area of four walls? I'll write down over here, area of four walls, area of four walls. Say sometimes we get the questions like that, where a man has to paint his house during Diwali or during Christmas vacation, I mean Christmas festival, and then that time he plans to paint his room on the four walls. So calculate his budget and so something like that, and some dimensions are given to you. So people don't understand what is supposed to be considered in that case. So in that case, we are supposed to consider area of four walls. So area of four walls in this particular case, it will become 4 into side square. Why 4 into side square, students? Simple. Why 4 into side square? Because in that case, this area and this area we're supposed to ignore, or we do not have to consider that. Are you getting it? So so we'll have to remove the two surfaces, the top and the bottom. We do not have to consider, isn't it? So 5 square, that will become 5 square will become 25. 25 into 4 will become like 4 into 5 square. So 5 square is 25. 25 into 4, it will become 100 centimeters square. I hope you understood this. Isn't it very, very simple? Okay, I hope you all have finished doing this sum along with me. This is very basic sums. Am I right, students? You must have found this is very, very simple to your standard. Am I right? But no worries, student. This is how the chapter is very, very simple. Believe me, the entire chapter, even the application sums, if you understand the concepts really very well, it's going to be really, really simple. Okay, now let's move further how to calculate the diagonal. I'm going to teach you that how to calculate the diagonal. So look at this. Say if this is a okay, basically this given example look like cuboid because the each surface over here or else the each dimension is different, A, B and C. So this looks like a cuboid, but student, don't worry, I'll explain you with this cube. Let's say imagine that all the surfaces are like A over here, or else all dimensions like length is A, breadth is A, and the height is also A. In that case, suppose we have to calculate the diagonal. So how are we going to calculate the diagonal? Simple. What is the formula of the diagonal? Come on, come on, come on. Try to memorize. What is it? Yes, correct. Okay, now I'll teach you why that it will become root 3a. One second. Just give me one moment. I'll just stretch the window. So students, in this part, I'm going to teach you how we derive first of all the formula for this diagonal. So first of all, understand we will going to take we're going to take these as a rectangle. Okay, these as a rectangle. Okay, the base one, like this would be A and this side will also be A, isn't it? This side would be A. If this is A, this is A, then even this will going to be A. One moment, students, just give me one moment. Okay, students. So if this is A, if this is A, and we are taking this right angle triangle, student, understand, we are taking these as a right angle triangle. Okay, these as a right angle triangle. So let's say this is also A, and this is a right angle over here, and this is also A. So what would be these diagonal? These diagonal, this particular, this red line which we draw just now. What will be that? It will become obviously A square plus A square. It will become 2A square. So this will become root of 2A. That will become by Pythagoras theorem. Am I right? And now this is again A. This is A. This is root 2 of A. So what will be this diagonal will going to be? Obviously, once again, here is like a Pythagoras theorem will going to get apply on this right angle triangle. Are you understanding? ये वाला जो particular right angle triangle है. So in that case, okay, I'll just shade for you all to understand. So this would be like, this would be your a triangle which I'm considering to calculate the diagonal. One second, I'll just clear this. Okay, now how to get that hypotenuse, and in that case, obviously, we're going to use again Pythagoras theorem. So diagonal will become, look at this. This is a diagonal over here in this case. So diagonal will become a square. Okay, basically diagonal square will become a square plus this base diagonal square. So that will become root 2a square, isn't it? Or root 2a the whole square. So diagonal square will become a square plus what will be the square of this? It will become 2, root 2 square will become 2, and a square will become a square. So diagonal square will become a square plus 2a square will become 3a square. So if I'll take the root, because we want the diagonal, so it will going to become root 3a. You understood why the diagonal formula is root 3a? I hope everyone understood that. Isn't it very interesting and very simple? And now, suppose someone has given you the side as equal to 5 centimeter. If suppose someone has given you, let's say this is 5 centimeter, you're going to calculate the diagonal. How are you going to do that, student? It's really, really simple. Root 3 into 5. So what will be that? It will going to become simply root 3 will have to supposed to substitute. So it will become 1.732 into 5, and then that calculation would be the length of the diagonal in centimeter. Look at this, 5 2s are 10, so 1 carried, 5 3s are 15 plus 1 16, 1 carried, 7 5s are 35 plus 1 36, and then that 3 carried. Okay, 5 1s are 5, 5 plus 3 8, and then that's it. Isn't it simple to calculate the diagonal of the cube whose side is 5 centimeter? I hope, student, you understood this everything systematically and nicely, and you've enjoyed learning also, isn't it? Now, if you have understood this nicely, pause the video over here nicely and write it down this whole story in your book quickly. Okay, if you have liked this, give a big thumbs up and write your comments. And if you have not understood something, please still write it down there. Yes, so we've not understood. I'll re-explain there and there itself. Okay.